look a little bit more in depth at our exponential functions. We've mentioned that we're dealing with this form, y equals b to the x plus c. We've even talked a little bit about what the graphs would look like. We could have a curve going down and to the right, or a curve going up and to the right. If our curve goes down and to the right, it is called a decay curve. And it means that our b value in our y equals b to the x plus c is greater than 0 but less than 1. So basically we have a fraction between 0 and 1, something like 1/3 or 3/5, right? Something between 0 and 1. If we have a curve going up and to the right, that is known as a growth curve, and it means that our b value is bigger than 1. In an exponential function, your b value will not be 1. Okay, so let's take a look at what this means. If we have something that looks like y equals 3 to the x, we could make a table and generate some values so that we could actually graph this thing. So here's our x values and our y values. Just like we've done in tables past, we're going to pick x values that are easy to work with. So again, -1, 0, and 1, the very easiest domain values to work with. So I'm going to work this problem 3 times, so I'll go ahead and write it out 3 times. We know how I like to get that done right up front. So we have y equals 3 to the x. In the first scenario, our x value will be -1. In the second one, x is 0. And in the last one, x is a +1. So we have y equals 3 to the -1, which is just 1 over 3 to the first, which is simply 1/3. So when x is -1, y will be 1/3. The next go round, we have y equals 3 to the 0. Anything raised to the 0 power has a value of 1. So when x is 0, y is 1. And here we have y equals 3 to the first, which is just 3. So when x is 1, y is 3. So let's go ahead and graph this. Move these things around a little bit so we have the space that we need. All right. Okay, so we're just going to graph our 3 points. Let's start with our first one. When x is a -1, y is 1/3. So when x is a -1, y is 1/3. About there. Our next point, when x is 0, y is 1. So when x is 0, y is 1. And our last point, when x is 1, y is 3. So when x is 1, y is 3. So we can connect these 3 points, and notice it's not a line, it's a curve. So we'll connect these 3 points. And we'll have a curve that looks something like that. This is a growth curve because it's traveling up and to the right. Notice that our graph never crosses the x-axis right here. It approaches it, but it never actually crosses. It straightens out, and it would go forever and ever and ever and never cross that x-axis. That's because as it approaches and flattens out, that x-axis kind of acts like a boundary. And that boundary is called an asymptote. I'll write that word out for you. Asymptote. And that's that boundary that the curve never crosses. It's not always going to be the x-axis, but you'll kind of see as you're graphing these curves that they kind of flatten out. And so there'll be a point that, you know, they'll keep getting closer to that horizontal line but never ever cross. All right. Let's take a look at an example of a decay curve. So if we had y equals 1/4 to the x, again we could generate our table. And again we would pick those same x values, and I would work the problem the 3 times, 1 for each x value. So the first time x is a -1, the second time x is 0, and the third time x is a +1. So here we would have y equals 1/4 to the -1. That negative exponent tells me I need to flip the fraction. So this would become 4/1 to the 1, which is just 4. So when x is a -1, y is 4. Our next one here, we have 1/4 to 0. Remember, anything to the 0 power is 1. So when x is 0, y is 1. And our last one, we have 1/4 to the 1, which is just 1/4. Okay, so let's go ahead and graph this one as well. Okay, so the points we're working with are when x is -1, y is 4. When x is -1, y is 4. When x is 0, y is 1. When x is 0, y is 1. And when x is 1, y is 1/4. When x is 1, y is 1/4. And then we can connect those. To make a curve. So notice this curve goes down and to the right, so it is a decay curve.